This section is only 2 videos, and it's nothing new, guys. All right. So feel free to just start on the homework assignment if you're comfortable with the chain rule, because that's what we're starting with. Okay. This first video is just really how do you incorporate the previous section with the chain rule? Okay. So differentiate the following. And let's see what we got. Part A, y equals e to the negative 3x. So remember the chain rule, right? Chain rule says if I have the derivative of a function inside the function, it's like the general power rule. We take the derivative of the outside, leave the inside alone, and multiply by the derivative of the inside. Well, if we do that, right, y prime, the derivative of the outside function, that's the derivative of an exponential. And the derivative of an exponential function is itself, right? That was the previous section. d dx of e to the x is just e to the x. We've got more stuff inside, though. It's kind of like the general power rule. So we'll leave the exponential alone because the derivative of an exponential is itself, but we do have to multiply by the derivative of the inside function. The derivative is the slope. This is a line. Negative 3x is a line. The slope of that line, negative 3. Or you could use the power rule. Y prime is going to be e to the negative 3x times negative 3. Usually we just write that as negative 3, e to the negative 3x. And there we go. We have our first derivative. That's basically the section, is the chain rule. Okay? Leave the exponential by itself, because the derivative of an exponential is itself. Multiply by the derivative of the inside, and you are golden. All right. Let's do some wackier ones. Y is equal to e to the parentheses 1 plus x cubed. Looks kind of weird, but just break it up into pieces, right? Derivative of an exponential is itself. But the chain rule says we do have to multiply by the derivative of the inside. The inside here is inside the exponential function. Multiply by the derivative of the exponent. So the derivative of 1 plus x cubed, we're going to have to use the chain rule again, or the generalized power rule. That first thing stays the same. And what's the derivative of the second thing? Well, bring down the exponent, leave the inside the same, subtract an exponent, multiply by the derivative of the inside. The derivative of 1 plus x is just 1. So if we combine all our like terms and write this in order, we should get 3 times 1 plus x squared times e to the 1 plus x cubed. Like so. Right? Derivative of an exponential function is itself. You may have to use the chain rule and multiply by the derivative of the exponent, the inside of the exponential function. All right. Now let's really do some wacky problems. All right. Part C, I love this one. Y is going to be e. Oh, it's easy, Jason. Raised to the e. That's kind of weird, Jason. Raised to the e. Jason, what are you doing? All right. We got a 3-story building over here, 4-story building, depending on how you want to count. What about e raised to the e, raised to the e to the x? Don't freak out. Let's do this in steps. Got the derivative of an exponential function is itself, no matter how ugly itself might be. But we have to multiply by the derivative of the inside. So multiply by the derivative of the exponent. This is the exponent, right? So the derivative, actually, I'm going to leave that circled. I like that. All right, that's going to be multiplied by the derivative of e to the x. So still silly, but not quite as silly. We've cut down one of the stories of the building, like attacking those cactus things in Super Mario. What are those things called? All right, so the first thing, let's leave it alone. E to the e to the e to the x. All right, let's look at the second derivative. Derivative of an exponential function is itself. Oh, just e to the x. Multiplied by the derivative of the inside. Well, what's the derivative of the inside? It's the exponent. So we have to multiply by the derivative of this guy. We're almost done, right? First two things we're going to leave alone. E to the e to the e to the x times e to the e to the x. Derivative of e to the x is just itself. We got this beautiful little derivative right here. There's some other ways of writing this, right? We're multiplying exponential functions. We could just add all the exponents together. X plus e to the x plus e to the x if you wanted. Honestly, I think the box thing looks nicer than this thing. This thing is like, huh? But I'll take either form. Okay. What a wacky problem. Jason, you really got us good with this one. Let's do one more. Part D. Y equals e to the x times e to the 2x times e to the 3x. And you go, oh, you're so mean. Why are you giving us a problem where we have to use the chain rule twice? Or the chain rule twice and the product rule twice? Jason, this is a nightmare. And I say, no, Jason. This problem's not too bad. Simplify first when you can, all right? If possible, simplify before taking the derivative. All right? And that will make all of your dreams come true. Because what happens if we simplify? We just add all the exponents. 1x plus 2x plus 3x. Oh, that's 6x. Now this is a much easier function to take the derivative of. So watch out, guys. Wait, can you hear that? Ow, it kind of hurts. It does pick up on my microphone. There we go. And now we take the derivative. Y prime, derivative of an exponential function is itself. Multiply by the derivative of the inside. We'll get 6 e to the 6x. I think I just lost some brain cells. Hopefully you're gaining brain cells by reading or watching this. All right, that's the derivative. And that's the section. Good luck.